Hi, I'm Harold Tobin from the University of Washington. I'd like to present to you today a little bit of information about the SZ4D initiative. SZ4D stands for Subduction Zones Through 4 Dimensions, and it's a planning effort actually underway right now that is attempting to define what a decadal scale initiative in taking the next big leaps in subduction zone research might look like in the US and beyond. So SZ4D is a program or a concept that emerged from a decade of thinking about what the next big steps in subduction zone science might be that culminated at a 2016 workshop in Boise, Idaho. At that workshop, which brought together hundreds of scientists internationally, a few key themes emerged. That the leading edge or the next steps in subduction zone science would necessarily or would benefit from involving specifically a focus on fundamental processes, fundamental geoscience, but that underlies the geohazards specifically that subduction zones engender. It would also involve really taking advantage of the fact that there is so much more in the way of time series analysis that can go on today, from real-time observations and high rate observations of geophysical processes, all the way through to the greater precision in geological process timing that we now have through things like magmatic crystal clocks and friction experiments. A subduction zone research program by its very nature would have to be international collaboration and coordination and recognition that all of the countries involved in subduction zone research can make progress moving forward together, and would take advantage of integrating science across both field observations and new kinds of data sets with new modeling, new experimental efforts, and geological analogs to build huge collaboratories for subduction zone science. So the report that emerged out of that workshop is sometimes called the SZ4D vision document. The cover is shown here, understanding the processes that underlie subduction zone hazards in 4D. And it really focuses on developing a path for these targeted experiments to make big leaps in understanding those processes, using comprehensive suites of measurements that would be taken in the same places over similar lengths of time to integrate across these many different processes. So SZ4D really has a vision of capturing and modeling emergent phenomena, things that might potentially have improved predictive power or forecasting power for subduction geohazards, or for simply understanding the processes that lead to destructive impacts. It's all about collecting data sets in 4D and then using models and using our understanding from analogs to really integrate those into an understanding of process. And so SZ4D has really focused in on, understanding these three fundamental types of hazards: tsunamis and earthquakes on the one hand, volcanic eruptions, and then slope failures, whether on land or at sea, landslides, and all the attendant processes that go along with those, including sediment transport. So the SZ4D initiative that I'll tell you about in a minute has developed and is really sort of distilled into 3 working groups so far that are working on defining the kinds of problems and attacks on those problems that we can take through the faulting and earthquake cycles working group, the magmatic drivers of eruption working group, and the landscapes and seascapes or surface processes working group in subduction zones. The vision document lays out an implementation kind of timeline to get from a concept or a vision to an actual blueprint for something at a very large scale, ambitious, integrated research program, which obviously just doesn't spring, from whole cloth without a lot of effort that goes into the kind of planning and identifying funding sources and ways to actually go about doing that. So the timeline that was established in the report and is being carried out now basically involves 3 major components. A science program, first of all, so defining the key scientific objectives and what sorts of research endeavors would attack those, potentially developing the concepts behind perhaps a funding agency level, set of objectives and priorities for a science program. As a key part of that, building a modeling collaboratory that could really bring together all of the different kind of modeling approaches and the sorts of things that folks involved in CIG are most directly invested in order to get things onto a common playing field and really take this power of all those models and work with the observationalists and and theorists to build integrated subduction zone process understanding. And then finally, a key element of developing concepts for and hopefully funding paths for major physical infrastructure, meaning what kinds of new observations or new instrumentation essentially in the field would be necessary in order to advance SZ4D goals. All of these things are taking place. NSF funded several proposals to start these RCNs, or Research Coordination Networks, for parts of the SZ4D program. So I chair the so-called umbrella, or the overall SZ4D RCN, and its steering committee that represents a wide range of disciplines. Torsten Becker at University of Texas chairs the Modeling Collaboratory for Subduction Zones, which is a key element in implementing, as we showed on the last slide. And then specific to the volcanic eruption understanding and response is the Converse RCN that Tobias Fischer at University of New Mexico chairs, and is also funded and is heavily overlapping in its objectives with what SZ4D is doing. Large range of NSF programs have put in funding in order to support these as planning efforts. And all of them were funded for 3 years, not to start the SZ4D initiative, but to build a blueprint and a plan for what that should be. Recognizing that the community has been very large and responsive to this SZ4D initiative, the recently published National Academy's decadal report identifying priorities for the NSF Earth Sciences ranked it as one of the top 5 kind of highest priority for development programs that are potentially coming down the line for NSF. So the overall umbrella goals has, or the overall umbrella for SZ4D has a few specific goals, turning that vision into an implementation plan for an initiative. That initiative, of course, we don't know what shape it will take at this point, but we anticipate and advocate for NSF, NASA, other funding agencies, NOAA, USGS, and so on, and the international partners to put together a research program and fund it so that we can carry this forward over a decadal or longer timescale. That scale and the scope then is an open question because we don't know the funding level and what the best approach to that infrastructure and the research funding program, data management system, collaboratories for computer modeling and other things all would take, what shape they would take. And so SZ4D is currently engaged in building the community with these 3 thematic interest groups I mentioned before, and the specific working teams or working groups that have that detailed charge to take the vision and turn it into a program or turn it into a proposed program. All of that is going on right now, and we're in the middle of it. I want to take a moment to talk about the Modeling Collaboratory, which probably many people are really familiar with in this CIG group. But that is a specific, group within the SZ4D overall push that is independently funded to bring together the modelers and bring together data, identify the fundamental problems and how to make major advances with high performance computing, but also the whole range and panoply of fundamental models and different approaches to that modeling, and how to really put it all together so that the sum is greater than the parts. So the Modeling Collaboratory is ongoing. It shares members with the steering committee from the SZ4D umbrella and working groups, and we're kind of working hand in hand to develop that aspect of SZ4D. So I think of SZ4D as being a broad initiative with very strong overlaps with both the Modeling Collaboratory and the Converse group, although there are parts of both of those that maybe aren't within the SZ4D initiative. Fundamentally, SZ4D intends to develop, the integrated science through experiments, through physical observations and infrastructure, through the numerical simulation, through the work that goes on rapid response to volcanoes and so on. And they share these goals in the center here of building a science program, building a community, data management, education and outreach, and so on. So when I talk about infrastructure, what I mean is that SZ4D has an interest in and is currently actively developing plans and blueprints for both specific targeted experiments, what scale and what scope of physical experiments to put, let's say, large multi-sensor type of instruments on volcanoes tied to space-based observations, LIDAR, and all the other things that can take place, potentially to build rapid response capabilities, or conversely for subduction zones, perhaps we're talking about large-scale onshore and offshore, high density real-time geodesy, real-time observational seismology, the geological analogs that go along with that, and everything else. So there's the physical infrastructure, including all those laboratory and computational infrastructure and efforts. And then the intellectual infrastructure to make all of that happen, meaning build a science program, build a cohesive and engaged and inclusive scientific community with communication, education, and outreach programs that bring this all to the much broader community of scientists and of stakeholders in the public at large. So just very briefly, the individual working groups include the Faulting and Earthquake Cycles Working Group that's really focused on addressing how both subduction zone megathrusts and the whole panoply of allied faults, other subduction zone related faults, create hazard. And in particular, understand how slip on those faults is governed by stress accumulation, potentially has precursory slip, distinctive foreshocks, and other things, as has been frequently proposed recently, and creates seafloor displacement and causes tsunami hazards. The Magmatic Drivers of Eruption Working Group is really focused on questions that surround fundamentally, as once magma is generated and is moving into the crust, how do those transcrustal processes that exist, all of the things that go on, in order to sequester and or transport magma and do the things that initiate eruptions at arc volcanoes, and what kinds of observations can we use to understand those magmatic processes to improve forecast models, from geophysical observations to gases and a lot of things that I don't have time to talk about now, but are all part of what the working group is addressing. Finally, the Landscapes and Seascapes Working Group is addressing the surface processes. Understand how major or large-scale subduction processes translate into landslide hazard, turbidity currents, and volcanic mud flows and other surface-based geohazards, and create those impacts. All of those working groups are going through a process right now of identifying all of the key hypotheses and key questions and what the observations can be made and how to prioritize them that will actually address those to create outcomes that we want, like that kind of improved understanding or direct forecastability of different processes. So this is sort of the traceability matrix approach, and all three working groups are taking this sort of very intentional and thoughtful approach to getting through these processes. So this is very much a program that's in the midst of its 3-year process. We started around the beginning of 2019 with the various research coordination networks, had some initial meetings, gathered a lot of input from the scientific community. 2020 has been interesting, of course, because we haven't been able to have some of the in-person meetings, but the working groups effort has continued uninterrupted, as all working groups have been developing those matrices and developing their notional experiments or the concepts for implementation. We're just at the point now, here in October 2020, where those first draft versions of the kind of implementation plan experiments are about to be presented from one working group to another internally, and then to our much broader community for input. All of that will be used to develop a draft implementation plan through the course of the next year, and we hope to be holding a large public workshop later on in the program so that we can finalize those implementation plans. All the while, of course, working with the funding agencies that will be responsible for turning these things into an actual initiative that has legs and can move forward over the next decade. Outreach and capacity building is an absolutely key part of what's going to be coming in our planning, as well as the science. I don't have a lot of time to talk about it right now. Data management and data structures is another thing. So I encourage you, if you're not already, to become involved in the SZ4D community. It's an open and inclusive community. We have all of these town halls and workshops going on. There's an upcoming town hall at the end of this month at GSA, for example. You can sign up at SZ4D.org, the website, and get updates from those working groups, respond to polls from the working groups with questions, and so on. We really want the SZ4D program to be built by the research community. So that's really the kind of the high points. We hope that SZ4D represents to the research community a science program, an investment in long-term observational infrastructure, all of the allied modeling, laboratory experiments in geology, and community building that will make that happen. This process we're in is to define something that currently is very much open-ended. It certainly has to span the disciplines and span land and sea in what we call an amphibious program. in order to make SZ4D a really viable and productive and convergent and transformative initiative for the future. Thanks very much for listening.